Hi folks, Dr. P here. This is prime factors 4. Determine the greatest common factor of each group of numbers. So in question A, we're going to be using what's called the division method or ladder method, where so the two numbers are 192 and 216. And put in a step like this, and then on the left hand side we're looking to put a prime factor of 192 and 216, and because both numbers are even, 2 would work. 192 can be divided by 2, and so can 216, as well as 2 being a prime factor. Then we do the division. 192 divided by 2 is 96. 216 divided by 2 is 108. And then we put in the next level like this. And then we repeat this process. 96 and 108 are divisible by 3. 96 divided by 3 is 32. 108 divided by 3 is 36. Again, we're dealing with two even numbers, so we can factor out a 2, which leaves us with 16 and 18. Factor out another 2, which leaves us with 8 and 9. Now we're done, because what's left at the bottom here, there's no common prime factor between 8 and 9 other than 1. So we're done, and we're looking now to determine the lowest common multiple of these two numbers. And the trick here is going to be I'm going to change color here. The trick is to take all of the numbers along the left edge here, multiply them together, and then take all of the numbers along the bottom here and multiply those together as well. So you can think of it as a lowest common multiple starts with the letter L, and this here, numbers that you're taking and multiplying, creates a shape like an L, right? So we take all of those numbers, and we can shorten this a little bit. Instead of writing them all out, we can start with 2. There are 3 2's we're multiplying, so it's going to be 2 cubed times 3, a single 3, times 8 times 9. And that's going to be 1,728 as the lowest common multiple for A. Okay. Let's have a look at B. In B, the two numbers are 112 and 165, so I'm going to use a slightly different method here. I'm going to use a prime factorization tree. So we're going to be doing a prime factorization of both those numbers using the tree method. So we factor out a 2, which leaves us with a 56. Factor out a 2, which leaves us with a 28. Another 2, which leaves us with 14. And then finally 2 and 7. And the goal here is to end up with prime factors at the tip of all those branches. So we're done with 112. Now we're going to do 165. You can factor out a 5, which leaves us with a 33. And then we just factor out a 3 and 11. Now, to determine the lowest common multiple using this method, what we would do is we would start by taking all of the prime factors from one of the numbers. So for example, this one, it doesn't matter which one. So in this case, we have 4 2s, so it's going to be 2 to the power of 4 times 7. Okay, so this product here consists of all of the numbers from one of the numbers, from 112 in this case, and then we add any number, any prime factor from the second one, from the second number that's new. Well, 5 is new. There's no 5 over here, so we're going to multiply it by 5. I'm going to add 5 to this. 3 is also new, so we're going to divide by 3. And then 11 is also new, so we're going to multiply by 11. So in this particular case, we end up actually using all of the numbers, but that might not be the case all the time. If we multiply all those numbers together, we're going to get 18,480 as the lowest common multiple of these two numbers. C. Let's go back to the ladder method. Two numbers are 360 and 378. Both are even, so they're divisible by 2. Leaves us with 180 and 189. We can divide these by 3. Sorry, 3. It goes over there. But 180 divided by 3 is 60. 189 divided by 3 is 63. We can divide this by 3 again, which leaves us with 20 and 21. And we're done. Now, if we take a look at the numbers at the bottom here, are we able to factor out another prime factor from 20? Well, yes, we can. We could factor out a 2. We could factor out a 5 as well. Could we factor out another prime factor from 21? Yeah, we can factor out a 3 or a 7. Both are prime factors. But we cannot factor out the same prime factors from both those numbers, which means that we're done. Okay, now to get the lowest common multiple, we take all of the numbers here in this L configuration. So it's going to be 2 times 3 squared times 20 times 21, which is 7,560 as the lowest common multiple. And then the last question here, now we're dealing with the lowest common multiple of 3 different numbers. I'm going to be using the ladder method here again. So the numbers are 322, 336, and 350. And the procedure is exactly the same. The difference is that now we're looking for a prime factor to put here that all 3 numbers have in common. And all 3 numbers are even, so we can factor out a 2, which leaves us with 161, 168, and 350 divided by 2 is 175. We can factor out a 7 here, the prime factor of these 3 numbers, which leaves us with 23, 24, and 50. And we're done. There are no other prime factors that can be factored out that these 3 numbers at the bottom have in common. So our lowest common multiple, we take the numbers in the L configurations, it's going to be 2 times 7 times 23 times 24 times 50, which is 386,400. And that's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See ya.